So we had, obviously started with first part of section 1.1, just talking about equations in one variable. We got through the identities, conditional equations, and consistent equations, and I think that's where, we did do the rational expressions one as well. So this is where we needed to get started. Equations involving absolute value. So can somebody tell me what do you understand by absolute value? And Annika, you can either unmute yourself, or you can put your response in chat if you like. Leave your video camera on though, please. So what do we understand by absolute value, just in simple terms? Perfect, very nice. So yeah, imagine on a number line, what would be the distance between the given number and 0? Now, when we talk about distances, do we normally talk about distances being positive or negative? Positive, right? Because, if we were talking about going to Denver, we would say we're going, how many miles do we go down to Denver? 30, 40? Make up a number? I don't know. Don't really drive down to Denver that much, unless, I really have to. All right, we'll settle on 40 miles. I don't know if that's accurate. So we would say we're going 40 miles south, right? Or we would say we're going 50 miles east, wherever we were going. So we don't normally say, negative 50 miles or negative, 1,300 miles somewhere. So think of that when you're thinking about absolute value. Since we are talking about distances become positive, but then, again, it just depends on what direction you're going. And in terms of the number line, obviously you could be going on the positive side of the number line, or you could be going on the negative side of the number line. But again, we're simply talking about distances. And that's the concept we use when we solve absolute value equations also. So you can kind of see in this case how we're defining it is we're saying if you have the absolute value of some number x, the answer would stay x if the value itself was positive, right? So if you had your x value as 3, absolute value of 3 would stay 3. That wouldn't change. However, if your x was negative, then you can see we actually take another negative sign on that number so that the two negatives can end up becoming positive. So that's the second example here. If you started out with a negative number, that means you're taking the absolute value of -3, and this is where we're introducing that extra negative sign. And the two negatives, as we know, end up becoming positive, right? So that's the math behind it. But normally we just say, hey, negatives become positive, right? That's kind of how we think about absolute values as numbers. So again, like I said, use that same policy when you are working with these equations. Now, when you're solving these equations, we do have to take into consideration that that number we're trying to find for x could be on the right-hand side of the number line, which is what we think of as being the positive side, or we could find that number on the negative side of the number line, right? So that's why we have to think about, am I looking on the positive side, or am I looking for that value of x on the negative side? And that's why normally you would end up with two different options when you're working with absolute value equations. So let's, oh, I forgot to fill up my examples from my math. Question. Yeah, that was the question. Let's do this one. So this one you can see is absolute value of 6x minus 16, and then it is set equal to -19. So this is something I want you to think about. Can a distance be a negative? Do we agree distance cannot be negative? Distance can be zero, right? I mean, if you're at the starting point, we can say we haven't really moved, so our distance is zero. But distance can be positive, it cannot be negative. So this is actually one of those trick questions that it's asking you, because you will see we've taken the absolute value and we've set it equal to a negative number. And when this happens, there is no solution to your equation. And it actually does mention in your, so if you look at that last, if you look at that last one where it says, absolute value of x equals k, and you can see they're telling us k is less than 0, which means k is negative. You will see as you move to the right, it tells us our solution set is an empty set. That's a symbol for empty set. So it's basically saying there's nothing in your set. And that's what the example we looked at is talking about, is we have an empty set because the reason is distances cannot be negative numbers. Alrighty, so that was this guy. Let's look at next example. Oh, I was hoping we could solve. All right, let's pick up one from here. So here you can see in number 10, we of course have x equal absolute value of x minus 4 equals 8. So 8 is a positive number. We can solve this. So if you wanted to solve this guy, it would be as simple as, and again, you can see this in your instructions here, if your number on the right hand side is a positive number, you break it up into two parts. Where you said it one's equal to the negative number and one's equal to the positive. Because remember, as I was saying, the solution could be on the positive side of the number line. The solution could be on the negative side. So we have to consider both options with absolute value equations. And then your solution set will come out to be two numbers, not necessarily the k value that you're starting out with, because this is just a generic form. So don't follow that, word for word. It's just guiding you. So the way we would solve number 10 is we would set this up as x minus 4 equals 8. So that's our positive setup. Or we could say x minus 4 equals negative 8. So this is where we're looking at, am I on the positive side or am I on the negative side of the number? And then what do we do to get x by itself? Yeah, add 4. So can you tell me what our two values should be coming from each side of the equations? All right, 8 plus 4 will give us 12. Negative 8, positive 4. So there's one number that's negative, one is positive. So remember, you subtract and get negative 4. So your solution set in this case would be negative 4. Normally, again, when we write that solution set in the, I don't know what they're called, curly brackets, we normally write the smaller number first and then the larger number. That's why I put the negative 4 first and then the 12. MyMathLab doesn't care if you did 12 first and then negative 4, it puts a count for the answers. So please, do you guys get an idea of how to set up an absolute value equation? Yeah? All right, so here's one of these that I want you to try on. Let's do 12. 5 plus 3 times absolute value of x minus 4 equals 0. Now, when you have an equation set up equal to 0, it has to be in this form. So it should be just the absolute value on one side and 0 on the other. Is number 12 in that format? Do we have just absolute value on one side and 0 on the other? No, so that's your starting point. Isolate the absolute value first. So you want to get the absolute value of x minus 4 by itself, so start by moving everything else to the other side. So again, remember, you're trying to isolate the absolute value of x minus 4 first, moving everything else to the other side. So just like you're solving equations, how do you get rid of the 5? How do you get rid of the 3? You're applying the same techniques. Are you not going to use the website for 22? So are we coming up with something that is any form of solution? Or if you're getting started? What is 3 doing with us? Let's have a so you can't just add that, right? Can we add 5 and 3? Because that seems to be a popular choice. Yeah? No? Yes? We cannot. Can somebody tell me why we cannot add 5 plus 3? Very nice. 3 is being multiplied into the absolute value. So remember, when there's no symbol, that automatically means multiplication. Because you think about how when we use parentheses, right? We would do 3 times x minus 4. So it's behaving in that same way with the absolute value. So since that's multiplication, you cannot just add 5 plus 3. So the first thing we need to do is get rid of the 5, move that to the other side. And how would we do that? What operation would you use? Subtraction, yeah, because it's a positive 5, so we would use subtraction to get rid of that. Okay, so we will start by subtracting 5, move that to the other side, which will leave us with 3 times absolute value of x minus 4, and then of course 0 minus 5 gives you negative 5. All right, now what do we do with the 3? Yeah, so again, since we know it's being multiplied, we divide by 3 to get rid of it. So divide both sides by 3. And we end up with absolute value of x minus 4 equals. So what would that give us then? How would we move forward from here? No solution. And why is that?
Can't have a negative absolute value.
You cannot have negative on the other side of the absolute value, so this is no solution. And this is the particular reason why I include these kind of examples, because we naturally think of, oh, there's 5 plus 3, so we're kind of going from left to right. Let's add those and then we can move it. But then you start thinking, oh, wait, the 3 is actually not free, right? He's tied up with that absolute value of x minus 4. All right, so now that you guys have done 12, I need you to try 11. And you can see it's kind of on the same theme as 12, right? But just set up different. So think about again, how am I going to isolate absolute value of x plus 5? And how am I going to get rid of the other stuff and move it to the other one? This one, I believe, if my memory serves me right, does have a solution. So you should be able to come up with an answer. Did you already have something? 0. Is it 0? Let me do the math. Well, I think one of the answers should be 0, but you should be able to come up with 2. Did you have
0
0 income? Yeah, Yeah, so yeah, it looks like you should be able to come up with two solutions. on your own. Anybody who's having trouble? All right, very nice, that's perfect. So now that you are here, you're gonna set it up like we did this time. So the two forms, so you will break it up. All right, very good, guys. So let's see. I can see you guys started out by adding the 10, which is exactly where you need to be. Which will leave you with 2 times, again, absolute value of x plus 5. And then 10 on the other side. 2 again is being multiplied, right? So to get rid of the e divide. Absolute value of x plus 5. And divided by 3 is 1. So this is where we started number 10 at, right? When we set it up into the 2 parts, and this is exactly where you are. So once you isolate your absolute value symbol, and as long as you have a 0 or a positive number on the right-hand side, we can find the solution. Again, like we saw with number 12, if it was negative, obviously we know we cannot go any further. So since this is a positive 5, you can set this up as x equals positive 5 or sorry, x plus 5 equals positive 5, or x plus 5 equals negative 5, and that's where the two answers. So you had told me 10, you want to change that number? Negative 10. So again, be careful with your signs, guys. We are subtracting 5, which will end up giving us x equals 0 here. X equals negative 10. So this solution, so I'm going to write it each one of them, would be negative 10 and 0. Just be extra careful as you're working through absolute value equations. This one is just an example of how we would use a linear equation to simplify. So they're not actually having you come up with the equation or anything like that. You will see they're basically giving you the equation, giving you some values and asking you to make a prediction. So let's take a look at this guy very quickly. They're telling you that X is the number of years after 1990. So that means 1990 becomes your starting point, right? And X is how many other years after that. They're telling us Y represents the median income in dollars for working women in the US. So they're telling us what those two variables stand for. So if your equation is Y equals 355.9x plus 11,075.3 models the real data, and they're giving you the source of that. In what year, to the nearest year, so rounding it up to a whole number, will the median income be $25,000? So they're saying basically after 1990, how many years would it take where the median income for working women in the US would be $25,000. So think about first, where do you put that 25,000 in that equation? Very nice, because Y represents the median income for women. And you know what? I'm actually going to do this here because PDF seems to be able to. All right, so our equation is Y equals 355.9x plus 11. Annika, are you able to see the notebook that I'm working on? Let's give it some time to, yeah. So once you plug in that $25,000 for the Y value, how would you proceed on finding the X? And what will your X value come out to be? So my computer does its little thing, go ahead and solve that equation to replace the Y with 25,000. It's no better than writing in Adobe if there's no point. Can you tell me what our X value came out to be? And it will give you a number. It is not going to give you a year. A year is what you will have to figure out once you come up with that X value. If anybody, can you tell me what your X value came out to? No, no, it should not be even close to that number. It's too large. 39? Anybody else? All right, so can you walk me through your math?
I just went to do 11,000 both sides, and then just divided that.
Very good, yeah, so start by subtracting the 11,075.3. Then, yeah, like you said, divide by the 355 now, since we need to get that x by itself. So actually, obviously come out to be a decimal number, but then we want to 5.3, but our instruction said to round it to the nearest year, right? So obviously then that means we are rounding it to 39 years. So if X value started in 1990, what year are you looking at if we're talking about 39? Did you say 23? I thought I heard you say 29. Yeah, because you're taking 1990, first 10 years would bring us to 2000, and then another 29 years would bring us to 2029. So we are talking about the median, which of course is a calculation for an average, right? We're talking about a median income for working women in the US in the year 2029, which is obviously another 6 years from now, when the median income will only be $25,000. Think about that. No household can run in that. I don't care what part of the country you live. And that is, you know, it kind of shows you that discrepancy that when we talk about in terms of income inequality, right? And that website, InfoPlease, is like a statistics website. So it kind of, you know, gathers all these different data and does different kinds of calculations. It's a pretty interesting website, but you know, I mean, you can kind of see how we can use something as simple as a linear equation to calculate something like this. You don't have to get into detailed, you know, fancy calculations to come up with these kind of values. Alrighty, so this was our just a linear example to show you how the modeling works. I'm kind of scared to go back and open. So there will be some. I'm going to try and open the handout from here. Maybe it will not. Couple more different types of equations. What we want to do. Oh, what is it else? So yeah, this is where we are getting into coming up with our own equation. So, you know, when they say constructing models, they're basically saying, okay, we're going to give you the scenario and you have to try and come up with an equation that will fit that scenario. Okay, so some of the common ones that you guys are probably familiar with is, of course, the distance, rate, and time formula. So we can obviously use this to find any one of those three given values as long as you know the other. The best way to remember this equation, I would say, is remember DIRT, right? D-I-R-T. So that will help you remember D equals R times T, or distance equals rate times time. In this case, when we use the DRT formula, we're obviously usually talking about uniform motion. So we're saying that constant speed, right? It will not accelerate or decelerate. Of course, one of the other common formulas would be anything for perimeter or area for different shapes, so squares, rectangles, triangles, trapezoids, rhombus. Most common one, of course, is area equals length times width for your rectangle. So we're basically saying, and these are all what we would call as functions. So when we're talking about a function, we're basically saying it's a rule for determining the value of one variables when you know one or more of the other variables. So in this case, the distance, rate, and time can be converted into, for d equals or r equals or t equals, and then as long as you have those other two values, you can find the third missing one. When they're talking about d is a function of r and t, they're basically saying d is based on the values of r and t, or we need r and t to calculate the value of d. A, in this case, we would say is dependent on length times width, right? Because area is based off those two measurements, so A would be dependent on length and width. So here they're just asking you to rewrite the formula so that you can kind of know how to rearrange them. So, in this case, when they're saying solve the formula for R, it basically means R would be your unknown value and you would know D and T. So how would you rearrange it and how would you solve it? And that's what this question was here. They're giving us n equals 9/2 q plus 17, and they're asking us to solve for q, which means they're saying get q by itself, move everything else to the other side. So let's take a look at how we would rearrange this guy. Now, those examples in the handout, remember I told you I have videos and notes for that in spring 2020 video lectures. You can find those solutions there. But let's take a look. And of course, you can see they've given us multiple choice to choose. So if we have n equals 9/2 q plus 17, and we're trying to get q by itself, what's the first number that you would move on that right hand side? 17, yeah, so let's start by subtracting 17. So that would end up giving us n minus 17 equals 9/2 q. All right, what would we move next? Sorry? So we've already moved the 17, right? Now we're trying to get q by itself. So what's the next number we need to move to isolate that q? And how would we move the 9/2? What operation would we perform? Say that again? Dividing would work, and we did talk about this on Tuesday as well. So remember, dividing is the same as, and I think you had given me the answer. Yeah, multiply by the reciprocal. So to get rid of 9/2, just invert or flip that fraction and multiply on both sides. Now, since you have n minus 17, that becomes one quantity. So remember, you're multiplying the whole n minus 17 by 2/9. Monica, are you okay so far? Did you have any questions? So that will end up giving us 2/9 multiplied by the quantity of n minus 17. That equals q. So which fraction, I'm sorry, which option A, B, C, and D matches that? A? B, yeah, because again, remember, since we subtracted the n with the 17 first, they need to stay in parentheses. So yeah, very nice. This one, this right here. All right, let's check our answer. Let's see what we got. You'll see there's a couple different examples. There's a linear equation here with ax plus by equals c. And they're asking you to isolate that for y. You can see that. This one over here, does anybody recognize what that formula is for? A equals 1/2 h times the quantity B1 plus B2. Anybody recognize that? No? It's the area for the trapezoid. Does anybody know what a trapezoid is? Otherwise it doesn't make sense when you say trapezoid. So it's got two bases, because remember with the trapezoid, one of the bases is shorter than the other one. And then when we talk about a perpendicular height, we talk about the distance h. So if I were to show you, just base one, base two, and the height we're talking about is that perpendicular height. So it's not these side measurements. That would be for the perimeter, but for the area, it's always that perpendicular distance between the two bases. That's your h. So basically, and I don't want to spend time on this one because I actually want to do the word problems. You can see they're giving you value for A, they're giving you value for H, they're giving you value for B2. So 4 of those variables is given to you, right? And then you're just finding that B1 missing over here. So if you plug those numbers in, you'll be able to come up with the area. And again, remember, as I said, you have these values in the spring 2020 video lectures. Alrighty, so let's talk about problem solving. So again, as I said, they'll give the scenario to you, they'll give you the values. You have to come up with an equation, you have to come up with a function, a formula, so that you can solve. So this is how they're talking about, problem solving. So obviously read that problem as many times as it takes so that you can understand, okay, what information am I given and what kind of information is given and what I'm trying to find, and then kind of go on, okay, so what kind of formula can I base this off? Is there something known that I can use? If possible, always drawing a diagram always helps. Choose a variable, write down what it represents. So let's say if you choose X, just make a quick note of X represents, like they said, number of years from 1990, or Y represents the median income for women. So just whatever you use, and normally I would say use a variable that maybe represents the value you're trying to find, right? So if it's height, I would go with H, right? If it's distance, D, that kind of thing. So once you have kind of that preliminary work done, write an equation that models a situation. You may be able to use a known formula like your distance, rate, and time, or area, perimeter formulas, or you may have to write an equation that models only for that particular situation. Once, of course, we come up with the equation, then it kind of becomes easy because then you plug in the known numbers, find the unknown, so that's your solving. Now, this would be crucial, checking your answer, because since we are coming up with the equations on our own, we want to make sure we did the math correctly, right? So checking your solution is a good step to go, and then make sure you have answered that original question that was, asked of you. So let's start out with this example here. So you can kind of see they're giving you an image to go with that, and I do have this problem pulled up in our So as you can see, we're talking about the saddle height on the bicycle should be 109% of the inside leg measurement of the rider. So you can see we're talking about when that pedal is at the bottom level and as you get to the seat, right? So that is the saddle height that we're talking about. So the saddle height on the bicycle should be 109% of the inside leg measurement of the rider. If your saddle height is 38 inches, then what is the inside leg measurement? So take a minute, think about this. Saddle height saddle height should be 109% of inside my. Do you guys remember some of the basic rules about setting up an equation? Like is supposed to be the equal to sign, of is supposed to be multiplication. Use that in here. And tell me what symbol would you put between the H, the 109% and the. Saddle height on a bicycle should be 109% of the inside leg measurement. Did you have something?
H equals 109% parentheses L.
Perfect, very nice. So the should be is acting as our is, so that's your equal to 109% of the inside leg measurement that acts as multiplication. And normally when we work with percents, what do we do? Turn into a decimal. So what will 109% look like as a decimal? Times. Yeah. Alrighty, so what information is now given to us in that second state? What are they telling us? Very nice. So they are telling us saddle height is 38 inches, which means that's your H value, and you don't even have to write the inches there. And then you're multiplying that, or sorry, setting that equal to 109 or 1.09 in this case times L. So how do we find the L now? The length, the inside leg measurement? Perfect, divide. And I'm going to move this over here, so we would take 38. Divide it by 1.09. And as I was telling you, Tuesday, you can see under the answer box in blue, they are mentioning how they want you to write the answer. So this is telling us either an integer or a decimal rounded to the nearest tenth. And I believe we might actually end up with a decimal. So can you tell me what our inside leg measurement comes out to? Rounded to the nearest tenth. Say that one more time.
34.9.
Perfect, very nice. So yeah, it's coming out to be 38.862, and it keeps going, but when we round it to the nearest tenth, that's 38.9. And what unit of measurement should this be in? What was our saddle height in inches, right? So of course, this will also stay in inches. Alrighty, perfect, guys. So let's put this in. Did I see 38? Sorry, that should be 34. Not even moving. So 34 point. Sorry about that. And then to box 34.9. Once you round. So just a simple illustration over here, guys. We didn't have a known equation for this, right? I mean, there was not like an area or a distance, rate, and time, but the setup of the equation was given to you in that very first statement. So that is kind of what they were talking about. Read the problem, see what information is given to you, and come up with your equation based on that. And that's exactly what we did with this guy. All right, here's another example. This one is kind of based on area perimeter. So now we're looking so you can see the whole thing. So here we can see a carpenter used 34 feet of molding in 3 pieces to trim a garage door. Now, obviously, as you know, with garage doors, we don't really have to put a trim at the bottom, right? So that's why you're only going on 3 sides. And so they're telling us The total he's using is 34 feet of molding, he or she, I guess, 34 feet of molding. If the long piece was 2 feet longer than twice the length of each of the shorter pieces, obviously, the longer one is on the top. So the long piece was 2 feet longer than twice the length of each shorter piece. Find that length of the long piece. And you can see in the image, and that might be a little bit hard, but on the shoulder side, they're giving you that length as, so they're kind of giving you the unknown variable. So your shoulder side is X. Based on that, and this is thinking in terms of a perimeter, but only 3 sides. What do you think that equation should look like? Let's focus on the image of it, and then that sentence of 2 feet longer than twice the length of each of the shoulder piece. What can we label the second shoulder side of our garage? What would that distance or measurement be? What should this distance be here? Sorry? 8? Let's stick with just one variable. You don't want to introduce new variables because the more variables you introduce, the more complex it gets. So we want to stick with everything in terms of X, since they're already giving us X. Now, think about a rectangle. Yeah, if this is a rectangle, this distance and this distance has to be the same, right? So both shoulder sides have to be X. So keeping that in mind when I'm going to then they're telling you the long piece was 2 feet longer than twice the length of each shorter piece. How would we write that out in terms of equation?
Long piece equals 2 plus 2 X.
2 plus
Yeah.
2x? Okay, so 2 feet longer, so that's the 2 plus, right? Because whatever the distance of the short piece is gonna be, this is gonna be longer than that, so that's the 2 plus. And then they're telling you twice the length of each shorter piece, right? Each shorter piece is X, so that's twice the length of X plus 2 feet longer, so that's going to be your long piece. Now, for a rectangle, and we're just gonna do this on the side, what is your perimeter formula? Somebody's gotta know that. Perimeter, right? If this was a complete rectangle, we were going all the way around, what would the perimeter formula? Really nice? Well, there's only length and width, right, to a rectangle, so you wouldn't really have 3 areas. How many lengths does a rectangle have? 2. How many widths does a rectangle have? So when you add all 4 sides together, you get the perimeter, right? So that means you're taking 2 times the length and adding 2 times the width. In this case, they asked us only for 3 sides, right? Because this is a garage, so this is a practical application. We don't need the second longer side. So we would modify and we would say our perimeter is going to be only 1 length. Plus 2 widths. So coming back over here, let's see how we would modify. I'm just gonna go ahead. Write this out here. So if you were doing the perimeter, it would be 1 length and 2 times the width. The long side we're defining as 2 plus 2x. The short side or the width is just x, right? That's what we're calling it, or the example of it. So now, replace this, we know the perimeter is 34 because that's the total length of molding that the carpenter is using, so that's gonna be our total perimeter. Our length is going to be this one here, so that's 2 plus 2x. And then our width, the W is just x, so that's going to be 2 times the x. That's going to be your perimeter formula. Questions at this point? Any part of it that did not make sense? All right, let's solve this then. I need to make space here. All right. So if we have 34 for the total molding, the 2 plus 2x for the long sides, the 2x for the 2 short sides. Let's see what your x value comes out. So simple equation solving, get your x values together. Isolate the x. Let's see what that means. And will x be our final answer that we're looking for? Is that what you're gonna type into that little answer box? The question was really what would be the longer side, right? But in the answer box, they're actually asking you for the long and the short, both of it. So what's your x coming out to be? 8. And that should be in feet. Alrighty, so of course, combine your two x values, which will become 4x. And then to get x by itself, we subtracted 2 on both sides. Which will then giving us 32 equals 4x. Very nice. Divide both sides by 4 and we give that 8. Now, is this for the long side or the short side here, guys? Sure, because that is the x value, so this is going to be our width in a way. So what is our length, our long side? That was how we started out, right? 2 plus 2x, so just replace that x with the 8. That's 16, 18. Okay. Let's see what this one is there. Long piece is 18 feet. Does that add up to 34 if we take 2 times of the 8 plus 1s of the length? Because 8 plus 8 would be 16, right? So that's the 2 shorter sides, and then what's 16 plus 18? 34. Yeah, so that's how you check your answer. And again, we could have done that check formally or as informally as we did right now, it doesn't matter. So you can see in this example, we based it off a known equation, which was the perimeter of a rectangle, and then we modified it because we only needed to use one rectangle. Okay, this is another one of our examples. This is what we call as a work problem. You're doing a task, and they're basically comparing how fast 2 different people do it. So you can see this one is talking about Trent can deliver his newspapers in 40 minutes. So that's the task. The work is delivering newspapers, and the time is Trent only needs 40 minutes to do it. And then they're saying it takes Louis 60 minutes to do the same route. So two different people, two different timings. So the question is, how long would it take them to deliver the newspapers if they work together? So this one is based on performing one task, which in this case is delivering newspapers. And it's based on speed, how quickly they get this done. So the way you set this up is, let's see how it is. So there's one task they are performing. It takes Trent 40 minutes. It takes Lois 60. So if this was their time, let's talk about their speed. So if it takes them, or let's talk about Trent, if it takes him 40 minutes to get his total job done, basically we would say in 1 minute, how much work would he have done? Okay, that's kind of what, per minute speed would be. So in this case, we would say he's basically getting 1/40th of that work done in 1 minute, right? Because you just take 1 minute divided by 40, that would be the same way we would set up Lois. In 1 minute, she's gonna get 1/60th of her work done. And then the way you set up this equation is you take both of their speeds, add that together. And they are doing one task, one job. And we are trying to find, basically, if they were to work together, how long it would end up taking them. So that would be any variable we want to talk about. In this case, we can call it, how long will it take them to deliver the newspapers if they work together? I guess for together, I'd call it T. How long would it take? So you're then basically multiplying each of these fractions by that time. So this is a general setup of when you are working with time problems. Or word problems, sorry, not time. Is you take, you take 1 over whatever the speed of that first person is, plus 1 over whatever the speed of the second person is. Add those two together, set it equal to 1, and then your numerator gets multiplied by whatever that unknown variable, and in this case, we're calling it T. So this could have been, oh my God, we've seen examples of raking leaves. Sometimes it's not even people related. You can, typing speed and stuff like that. Sometimes it can be about machines. 2 pumps, 2 different pumps. How long does it take for one to empty a pool? And, it takes this one that much longer. And then the second pump would take this much longer. So when 2 pumps are working together, how long it takes? Same exact setup. So it doesn't have to be just people. It's just any task, any work being done. And how would you come up with that? So that's your equation. This one would be something, if you have not worked on these kind of problems before, then it can take a little bit of coming up with the equation. So just remember, this is your setup for it. Now, how would you go about solving this? How would you go about trying to find the solution to this? Where do we start in a problem? And we talked about solving fractional equations last time, the rational equation. So that's the property you're using here. Very good. We need to find a least common denominator. So between 40 and 60, what will be our least common denominator? No, it's got to be a number larger than 60. And you can actually honestly just think about this in terms of 4 and 6, and then the zeros can just come in later. So if you were just looking at numbers 4 and 6, what would be a least common denominator between? 12, right? Because 6 times 2 is 12, and then 4 goes into 12 3 times, so that would be the same thing in this case. The LCD between these two would come out to be, and like I said, just add that extra 0 at the end, would be 120. So what do we need to multiply this fraction by, and what do we need to multiply this fraction by? So 40 gets multiplied by what to turn it into a 120? 3, so very good, multiply this by 3 and 60.
2.
The other thing you could have done is taken the entire equation, and again, I showed you this last time, taken the entire equation and multiplied it by 120 also. You can do it that way, so that helps you get rid of fractions. So this would end up giving us, let's see, 3t over 120 plus 2t over 120 equals 1, and you can see we will still need to multiply everything by 122. You can get rid of the fractions. So that would end up giving us 3t plus 2t, because on the left hand side we cancel out, and then 1 times 120. All right, solve this. What do you get for your t value? Did anybody else get that answer before? Yeah. Okay, the 5s cancel out.
Yeah.
Okay, you want to tell me what you did?
Just did it like fraction, just did it at the end.
Oh, but you just didn't use the t value. Okay. Yeah. Yeah, very good. It will come out to be that. So obviously you can see, since these are now 2 people working together, it reduces your time significantly, right? I mean, now it's not taking the first person 40 minutes, the second person 60 minutes together. They're getting it done in almost half the time of that first person at 24 minutes. So I just keep in mind this setup, because you will see examples like this in your homework. That, will have you work on work problems. Annika, did you have any questions at this point? And you can see there's all kinds of different examples that are in your handout. This is kind of similar to our garage example. This is the working problem I was talking about, and this one we went with Batman and Robin cleaning up crime in Gotham City. This is a mixture problem where you're mixing different concentrations of liquids or chemicals, and you're trying to figure out what, the total would be. So I think I did see this one in our one. Alrighty. So this one we're talking about, we're trying to find the quantity, but that would depend on the concentration also. We're taking 80% of antifreeze solution and mixing it with 70 gallons of 25% antifreeze to get a mixture, which will be our final result of 70% antifreeze, right? So you're taking 80%, 25%. So since one of them is a much lower concentration, your mixture will drop, right? From 80% to 70% in this case. And so they're telling us we're using 70 gallons of the 25%, but we don't know how many gallons of the 80% we're using. And then we know the resulting would be 70% of whatever that total is. So again, when you're setting these kind of problems up, since we don't know how many gallons, let's call that X, okay? So you have to multiply the concentration with the quantity of the solution. So you're basically taking X times 80% of that first solution. We're mixing it, which means you are adding, right? And we know this is 70 gallons, so that's gonna be 70 gallons of the 25% concentration. So that will equal, what's my total quantity for the mixture that I got? Not just. I'm asking for quantity, not the concentration. How many gallons will my mixture be once I mix these two liquids together? How would you write that? Yeah, exactly, X, because we don't know how much of the 80% solution we're using, but we're calling it X. And we know 70 gallons of the second solution, so this will be X plus 70 for the quantity. And then you're multiplying that by the concentration of 70%. So each quantity gets multiplied by the concentration. Think about it that way. We don't know the first one, so that's just X times 80%, that's one part. The second mixture, the second part of the mixture was 70 gallons of the 25%, so those go together, that becomes our total. Equal to, we know it's gonna be X of that first liquid, 70 gallons of the second liquid, put them together, and then my new concentration would be 70%, so that's how you break this down. Again, guys, convert the percentages into decimals when you're working with this, so what's my 80% going to be as a decimal? Yeah, so 0.8 times X plus, what would be the math for 70 times the 25%? Yeah, so 70, basically 70 multiplied by 0.25, which will give you 17.5 quantity. And then this one we need to distribute, so I'm gonna, I guess, break it down for you guys here. So X plus 70, and then you're multiplying it with 0.7, so that would actually then means we need to distribute, right? So you would be multiplying 0.7 with X and 0.7 for the second. Can you tell me what that will end up looking like?
Plus 7.
Plus 7. Yeah, it is. Seven.
What's 17 over?
The decimal and the zero will essentially cancel each other out. And you end up with 7.7. Alrighty, so we've got X's on each side, we've got constant terms of each side. Go ahead, solve that and tell me what your X is coming out to be. How many gallons of the 80% solution of it? Alright, get your X's on one side, get your constant terms on the other side. What did you know? Okay. Can you subtract the two? Yeah, and then you will, once you combine your X values, then you'll need to see what that gets divided. Yeah. 315? Anybody else want to do this? No, it's definitely gotta be more than that, because that means only one down, right? If you were looking at that. Okay. All right, we've got at least, I think, 5 people with 315, so let's take a look quickly. Obviously, when you are subtracting the two x values, I'm just gonna move the smaller number over. So that will end up giving us 0.1x here, and then I'll subtract the 17.5 from 49. Draw, I think this is where you guys have the. So yeah, when we divide by 0.1. It comes out with balance. And if you think about this, just take a quick second, you're only going from 80% concentration to 70%, right? So not even half of the original concentration. So that tells you, since you're bringing that 70 gallons of the 25% antifreeze solution in there, even after that, it's not that much of a dilution that's happening to bring your concentration down too much. So yeah, that quantity of the 80% solution has to be pretty high to only go from 80% down to 70% concentration. So 315 might seem like a large number, but it's actually not. It works in this case. Questions on this one, guys? You doing all right? Yeah. Okay, so I've tried to give you multiple different examples to show you how to come up with that equation on your own. Some of them are set, based on known information, like I said, dirt formula or area perimeter, and then some of them are just based on the type of question you're looking at. Alrighty, guys, this brings us to the end of 1.2. Alright, this is kind of what I was hoping to get into. If I do have an activity for us, which we'll do next class, but we can please set it up for now. So we've mainly looked at equations with one variable, in section 1.1, and we kind of built up on that with section 1.2. Now we're getting into, of course, our equations in two variables. So this is where we bring both x and y, kind of like the median income example, but we didn't come up with the equation, they just gave that information to us. So in this case, once we get into equations with two variables, we are talking about the two-dimensional coordinate system. So that's, where our x and y axes, or the rectangular coordinate system, or the Cartesian coordinate system comes into place. Of course, it's named after René Descartes, French mathematician, philosopher, who came up with that. So remember just some terminology to get you guys acquainted with. When we write a solution to an equation in two variables, we write it as an ordered pair, but that ordered pair also represents a point on the graph, right? So the x, of course, corresponds to the horizontal axis, the x-axis, and the y corresponds to the vertical axis, the y-axis. Terminologies, of course, x is called the first coordinate or the independent variable, y is called the second coordinate or the dependent variable. Your rectangular coordinate system is broken up into 4 quadrants. Does anybody know in what order those quadrants go? Clockwise or counterclockwise? Counterclockwise, very nice. Yeah, so it begins with quadrant 1, where both x and y values are positive. Quadrant 2, again, so counterclockwise. X values are negative, y values are positive. Quadrant 3, and we do use Roman numerals when we're writing the quadrants out normally, would be both negative values. And quadrant 4 would be, positive x, negative 1. Okay, so you have points that fall into the quadrants, but then you also have points that would fall on the axis itself, right? If your point is on the x-axis, what are all your y values going to be? If your point falls on the x-axis. Very nice, your y values are going to be 0. And in that same way, if your point falls on the y-axis, what will your x be? 0 again. So remember, if your point is on the x-axis, all the y values are 0. As you can see at this point, you are corresponding with the 0 on the y-axis, so all the y coordinates will be 0. If your point falls on the y, that means you're looking at the x value. They're talking about plotting points, so normally when you are plotting points, if you had something like -3, +4, you always start with the x value and then go to the y value, so you would be going -3, so that's on the left-hand side of the x-axis, and then 4. If you haven't done graphing in a while, the orientation homework, I believe, helps you practice with that, but there should be some points you'll be practicing over here also. So you can see, given you different points, just looking at the coordinates, can you tell me in which quadrant 4 of these points will fall into? So what quadrant is -3, -2? Very nice, this is going to be a quadrant 3 point. -1, +3. 5 halves and 0. Because your right coordinate is 0, right? It's not going to be a problem. Which axis? X-axis. And the 2 negative. So we're kind of actually tying up how the Pythagorean theorem can actually be working with the coordinate system. So of course, we know Pythagorean theorem is when we use it to find the sides of the length of a right triangle, right? If one of the angles has to be 90 degrees. So as you can see here, this would be the angle, which would be 90 degrees. So the side opposite from that is always the longest side of the triangle. That's what we call as the hypotenuse. And then the 2 shorter sides are what we call as legs. Again, your formula is you take the square of each of those legs, add them together, and that gives you the square of the hypotenuse, right? A squared plus b squared equals c squared. Now, if you wanted to superimpose this on top of a coordinate plane, this is what it would end up looking like. So you can see we've taken 2 points over here, 1 point over here, and when we connect them together, it forms that right triangle, because again, this is my 90-degree angle right over here. So if I use that same idea of a squared plus b squared equals c squared, but now change it, now I'm talking about that horizontal difference, so that is the difference between the 2 x values. So that's going to be x2 minus x1, and they're using absolute value, but you don't have to, because we still have the square on that. So any negatives would automatically become positive. So you can actually change those to parentheses. So that would be the horizontal distance between those 2 points, the distance for A, one of our legs. To calculate this distance here for B, that would be the difference between our 2 y values. So that becomes the B squared. And then this would, of course, equal the hypotenuse, which would be this distance over here. And since we're trying to show you how we go from Pythagorean to the distance formula, they're calling it D. And that becomes your D squared. And that is basically what the distance formula is. The distance formula is the Pythagorean theorem rewritten on a coordinate plane and converted into a distance formula to show you the distance between 2 points. And the main 2 points we are interested in was figuring out the distance between this point here and this point here, but using the Pythagorean theorem to get there. You will see examples of the distance formula questions here. So you can see again from the Pythagorean theorem, this is what we come up with. But we don't really want d squared, we just want d by itself. And so to get rid of the square, we use square root. And that's where this formula comes from. And this is something you can keep handy as you're working through examples. So again, essentially, it's the Pythagorean theorem that is being rewritten as a distance formula. So let's do a quick example here. Okay, we'll just do this example. So these are our 2 points. It does help to label them. So you can say this guy is x1, y1 here, and this guy is x2, y2. So that when you put it in your distance formula, distance formula is square root. Again, remember, you take the difference between the 2 x values, and it honestly doesn't matter which one you label as x1 or x2. The math will work out as long as you keep track of your signs. So we're doing x2 minus x1, so that's going to be 1 minus, and then since this guy also has a negative sign, I'm going to put that in its own parentheses. So x2 minus x1, square that, plus y2, which I've labeled that as 2, minus y1, which is 0, and again, clean it up, let me see what your distance comes out to. It may not come out to be a happy number. Sometimes you leave the square root, sometimes you can simplify it. It will just depend what this guy cleans up into. This time we have. What do we have? You have something? Square root of 8, okay. Anybody else? You go too? Yeah, alrighty. Yeah, because I mean, look at that. You're doing basically negative and negative would end up becoming positive here. So these guys add up. 1 plus 1 will end up giving us 2. And then we're looking at 2 squared, which will of course be 4. Same thing here, 2 minus 0 is 2, and you're looking at 2 squared, which is again 4. And all of this is under a square root. And this will end up becoming, let me write here because again my right hand is working out to square root of 8, right? Does anybody know how to simplify a square root? Eight can be broken down into 2 times 4, right? Because we're always looking for that perfect square to break these down. So 8 would be the best to do as 2 times 4. 2 does not do anything because it's not a perfect square, but we know square root of 4 is 2. So that will come outside and become 2 times square root of 2, and this is how you simplify radicals. More than likely, they are not going to want a decimal answer here. Because you know, if you plug this in into your calculator, it's going to spit out a decimal calculator, unless decimal answer, unless you have one of the calculators where you need to format that to give you an exact answer. So that way it can give you the 2 square root of 2, so you may just have to do a little formatting. So be careful, read the instructions in My Math Lab. Don't type a decimal answer in if they're not asking for a decimal. But that's what the distance formula is. Questions on this one, guys? The other one is what we call as the midpoint formula. So it's the same idea of if you have those 2 points, you're basically trying to find that halfway point. What would that midway be? So they're kind of talking about, think about if you were working with real numbers, you would take the two numbers and divide that by two because that's its half, right? And that would give you the halfway distance. So we use that same thing, but with ordered pairs. So since we're trying to find the midpoint between two numbers, x1, y1 and x2, y2, you basically take the two x values, add them together and take its midpoint, take the two y values, add those together, go halfway through and get its midpoint. So this is the same one that we just found the distance for. And we can find its midpoint here very quickly. So again, I'm just labeling these x1, y1. Y2, so for my midpoint, that would be adding the two x values together, so that's -1 + 1 divided by 2. And y values are 0 + 2 divided by 2. So what is that midpoint look? Because you're adding the two x's together, right? And the two y's together. Okay. So -1 + 1 becomes 0, right? 0 divided by 2 is of course going to be 0. 0 + 2 is 2, so 2 divided by 2 will become 1. And just to show you very if we are talking about -1 and 0, that would be here. And then -1 and 0, and then 1 and 2 would be here. So when we're talking about the midpoint, you can see that midpoint between these two would fall. We got the distance as square root of 8 or 2 square root of 2. Your midpoint is at 0, 1. So simple stuff. But again, as you move forward, you will see we're going to be using these for different applications, different examples, and one of them is right over here, which you guys can again see that in the video lectures if you go to spring 2020. But how you can use that to prove, where your 4 vertices on a square are going to bisect, and remember bisect means it's cutting it exactly into half. For a square, if you take the two diagonals and cross them together. So we're actually going to begin with circles next time, guys. Again, do not fall behind on your homework. Remember, we have 3 sections from chapter B and chapter 1, and now we're in section 1.3. So please don't fall behind. Don't think I can catch up on this the day before that exam. Let's try and stay on top of our numbers. Okay, guys? And if you have any questions, stay back and I'll be happy to answer. All right, have a wonderful weekend and I'll see you guys here on Tuesday.